Describe the nature of the turning point. Y is equal to x cubed minus 6x squared minus 6x squared minus 6x squared minus 6x squared x cubed minus 6x squared plus 12x plus 12x plus 12x plus 12x plus 12x minus 5 minus 5. So describe the nature of the turning points of the function. Y is equal to x cubed minus 12x plus minus 6x squared plus 12x minus 5. So let me write it. So we have y is equal to x cubed minus 6x squared 6x squared plus 12x minus 5. Let's do this. Who's done with the question? Who's done? Where do you guys, please? Ruben, what did you guys? Okay. Who else? PSC, are you done? Asha, what did you get?
I'm not done.
I'm waiting. Please hurry up. So let's do it. So the first thing we are going to do is we are going to find the dy dx of this one. We are going to differentiate with respect to x. So we are going to get dy slash dx is equal to 3x raised to the power 2, right? Minus 12x plus 12. Am I right? Am I right?
Yes.
After getting
Yes,
this,
sir.
then we are going to find for the second.
Yes,
Uh,
sir.
after getting this, we are going to equate this one to 0 and find the x values. So that's we are finding for the turning points. So for the turning points, for the turning points, for the turning points, dy dx is equal to 0. For the turning point, dy dx is equal to 0. So 0, 0 is equal to 3x, 3x squared minus 12x plus 12. What are we getting? X is equal to, what are we getting? Please use your calculators.
2.
What are we getting?
2.
What do you get? Oh, hurry up.
2. Say 2.
So x is equal to 2. 2 and
So you
what?
have 2, yes.
Okay. So x is equal to 2. So when x is equal to 2, we have to find its corresponding y value. Or so its corresponding y value will be y is equal to. We come and factor the 2 into this one. Now we want to get to the nature of it. That is the turning point. So we have to get the nature, whether it is maximum or the points are maximum or minimum points. So what are you going to do? You substitute 2 into this one. What are you getting? When you substitute into this equation, what are you getting? Into the y, what are you getting? Y is equal to, remember 2 raised to the power 3, that will give us 8. 8 minus 12, is it 12? 8 minus, this is 6 into bracket 2 raised to the power 2 plus 12 into bracket 2 minus 5. Let's do the mathematics and let's go. Now I'm going to get y to be 3. Am I correct? That means our turning point now, our turning points now becomes into bracket 2 and 3, right? 2 3, 2 slash 3. This will be our turning point. Now the question says we should find for the nature of the turning point. So to find for the nature of the turning point, we have to find for the second differential of y. So we are going to differentiate this one again and equate it to 0. So when you differentiate that, we are going to get dy slash dy squared plus dx squared. What are you getting? What are you getting?
6x minus 12.
So I'm going to get 6x minus 12. 6x minus 12. Now, when we put x is equal to 2 into it, what are you going to get? X is equal to 2 into this one, what are you going to get? It's 12, okay.
0.
0. So you realize that if you had 4, then that means you are saying 4 is the y, the 2y or all over the xy. When it is greater than 0, then you are saying that the stationary point is minimum. When it is less than 0, you are saying that the stationary points, they are maximum. Now when it is 0, then we are saying that the points are points of inflection. Are we getting it? So for instance, if we place the 2 in this and we're able to get maybe 12, then we are saying that these points are minimum points. When it is greater than 0, they are minimum points. Now when it is less than 0, then we are maximum points. I hope you remember. We did it last week. Do you remember? Now, after finding the distance, after finding for the turning point, if there's second differential, which is the y squared all over the x squared, the squared y all over the x squared is equal to what do you call it, 0, then that means the points, they are not considered as points of minimum or point of maximum. They are considered as points of inflection. Have I made myself clear?
Yes, sir.
So do this one for me. Do determine the nature of the turning point of the following functions. A. So we are doing like 3. A. Y is equal to x squared minus 6x plus 2. A. Y is equal to x squared minus 6x plus 2. Y is equal to x squared minus 6x plus 2. B. Y is equal to 2 minus 2x squared minus 4x. So A. Y is equal to x squared minus 6x plus 2. Y is equal to x squared minus 6x plus 2. B. Y is equal to 2 minus 2x squared minus 4x. Let's do the 2. The B is y is equal to 2 minus 2x squared minus 4x.
Stop.
Immediately, I don't know the network. Immediately turn off your distance, then it starts making noise. So let's do it. Y is equal to x squared minus 6x plus 2. So the first thing I'm going to do is I'm going to find the y dx. So the y dx will be equal to, what are I getting? 2x minus 6, right? 2x minus 6. 3 minus 6. So let me equate it to 0. So 0 is equal to 2x minus 6. X is equal to, what will be x? X will be equal to 3. So this will be our x. Now you find for its corresponding y. y will be equal to, we put 3 here, so 3, so this one will be 3 squared minus 6. Oh, that's, don't, minus 6 into bracket, 3 plus 2. So that will give us y is equal to 3 squared will be 9. 9 minus 6. 6 into bracket 3 is 18. So my 9 minus 18 plus 2, what are you getting? 9 minus 18 plus, what are you getting?
-3.
-7.
So minus 7. So now our turning points are equal to 3 minus 7. Now from here, we have to find for, what do you call it? We have to find for the nature of the turning point. To find for the nature of the turning point, we have to find for the second derivative of it. So find for the second derivative of it. dy squared all over dx. What are you getting?
2.
We are getting 2. And 2 is greater than 0, right?
No.
Oh.
Yes.
So that means the points are.
Minimum.
Correct. So the points are minimum.
Minimum.
Good. Now the second one too. The second one is, so with the same thing you can be able to do it. So if it is equal to 0, then that means the points are points of inflection. I hope I've made myself clear.
Yes.
Good. That is it. Now from here we are going to do applications of minimum and minimum and maximum. So that is it. So I hope I can clear the board. So let me clean the board. I'm cleaning the board. I'm doing applications of let me. I can't even eat unless I listen. So that is it. Now to determine the maximum or minimum of a value of any quantity, say P, we first have to express the P in terms of another quantity, say T. And the equation is determined from the information normally provided from the particular question. Then we find the value T that will make P maximum or minimum. And so for instance, when you are given, when the question says that we should determine the maximum or minimum value of any quantity, say P, we first will express P in terms of another quantity. That will be say T. Now after finding for that, definitely the equation will give us informations about the problem provided. Then we find the value T that will make the P maximum or minimum that we are finding for. And hence the maximum and the value, maximum or minimum value of P. And so we are going to, basically that is what the application of maximum and minimum values are. And so we are going to, when you are given a quantity, you first express that quantity in another quantity. That will help you, and based on the information you are given, that will help you to be able to come and find the minimum and maximum of that quantity you've been given to find, or you've been asked to determine. So for instance, find the greatest possible area. For instance, the question reads, find the greatest possible area if 200 cm, if 200 meters of fencing is to make a rectangular enclosure. Now, so let's use this question to understand exactly what you mean by the application of maximum and minimum. When the class ends, you join again. So let me draw a thin line here. So find the greatest possible area of 200 meters of fencing. Find the greatest possible area if 200 meters of fencing is to make a rectangular enclosure. Now, if you have a rectangle like this, when you have a rectangle like this, you know the rectangle has two sides, or it has four sides, but two equal sides. And so let's name one of the parts. Let's name here maybe xcm. That's the distance. And here will be ycm. Now, when you are given a rectangle, there are two things we can consider. We can first consider the parameter of the rectangle, and you can also consider the area of the rectangle, which the question says we should find. Now, to find the greatest possible area, if 200 meters of fencing is to make a rectangular enclosure. And so we have, number one, we have area, and we have, what do you call it? Parameter here. Now, let xcm and ycm be the length of the size, the rectangular enclosure. So that is what I've already done. So if the parameter of the fence is, now the question says that if 200 meters of fence is to be used, that means the whole of this, the parameter of this is 200 meters. And so that means we can equate parameter in terms of this. So my parameter will be equal to 2x plus y, 2y should be equal to 200. I hope you know this. So that means twice of this and twice of this should give me 200. Because that is saying that 200 meters of fencing. So there's a fencing to make a rectangular enclosure. So that is it. And so we have this. So because since 2 is common, we can decide to divide through by 2. That will give us x plus y is equal to 200. Oh, sorry, it's equal to 100. So we can also get this. Now we can say that, okay, y, this is mathematics. So we can now say that y is equal to 100 minus x. Now from here, the area of the fence, the question also says you find for the area. So the area of the fence is equal to, area of a rectangle is xy. But we know that y is equal to 100 minus x. So now we can say a is equal to x into brackets 100 minus x. What are you getting? You can get a to be equal to 100x minus x raised to the power 2. That's what we can get. Now after getting this, we now have the area. Then now we come and differentiate. Now we are come to find the minimum and the maximum value and so on and so forth. And so we have this. So now we are come to find for dA all over dx. So we are first coming to find for dA all over dx. So dA all over dx will be equal to 100 minus 2x. Now we have to find for x by equating the 100 minus 2x to 0. We are doing applications of minimum and maximum value. So the first thing you have to do is first being able to get your facts right. Then now when you're able to put your facts together, you can definitely do your follow the normal principles of finding for minimum and maximum values. So x will be, when we equate it to 0, x will be equal to, who can tell me the answer? X will be equal to what? 50. 50. I hope I'm correct. X will be equal to 50. So dA dx is equal to 0. So x will be equal to this thing. Now we have to find for dA squared all over dx. Let me shift this one here. So dA squared you can now factor this into the main equation and find for its corresponding one, but let's do this. So dA squared all over dx squared. What are you getting? What are you getting? What are you getting?
-2.
-2. So answer is -2. So after getting -2, then we can conclude that at x is equal to 50, what do you call it? Or 50 is the maximum point, right? 50 is the maximum point. So it's negative, so maximum point. That will be the maximum point. Now to find for its corresponding y value, what we are going to do is, and its corresponding y value will be the greatest value that the question was trying to say we should find for. Is it find the greatest possible area? And so now after finding for this, a is equal to, the greatest possible area is a is equal to this one, 100 x minus x raised to the power 2. So when x is equal to 50, then a will be the greatest possible distance you are looking for. So what are you going to do? You are going to get 100 into brackets 50 minus 50 squared. What is a? What is a, please? What is the area, a? This will be 1005. Oh, yes, 1005 minus 50 squared. 50 squared is 50 squared is what? 250, 2,500 or something. Please do the mathematics and let me write.
It will be 2,500.
2,500.
So a will be equal to 2,500, and it is area, so meter squared. So basically that's what. So the question says that find the greatest possible area if 200 meters of fencing is to make a rectangular enclosure. Now when we talk of 2 meters of fencing, then we are also talking about the perimeter here, which would have to do with the size and so on and so forth. So we first have to have an equation for the perimeter, and we come and substitute that into the that of the area, because the question says we should find for the area instead. And so now a becomes our y in this case, and so a will be equal to our substitutions. That is it. Then we come and differentiate with respect to x. When we differentiate with respect to x, then we equate it to 0. Then we find our x value. When we find our x value, then if you want to know that the x value we found or the values we found are either maximum or minimum, we differentiate it again. Then we're able to find for that. Then we substitute it into this thing, our main equation, which is the a, because the question says you find for the greatest area. So A is equal to this. We just have to do the 50 into that. We could have just done it right away from here. We could have just done it right away from here. So we have 2,500. So 2,500 is the greatest possible area. The class will end very soon. You join again, then we do some more questions so that we get more understanding about it.